This is the Unit 5.6, Solving Systems of Inequalities. And so we've been solving systems of equations for a while now, and you should know how to solve these systems by graphing. Well, we can solve systems by graphing. We can solve systems by any of the methods that we've used. You just have to watch out for the signs. And now, solving systems of inequalities, remember, anytime we deal with inequalities, the rule is if you multiply or divide by a negative number, you have to flip the sign. That's the main thing to keep in focus. All right, so let's do a little bit of like just vocabulary stuff first. A system of inequalities, it's going to be the same definition as equations. It's just we're using inequalities and we're having more than one answer. So two or more inequalities graphed on the same coordinate plane. Now remember, you can always pause this video, take the notes, and unpause whenever you get the notes written. A solution to a linear inequality is it must be in the shaded area of both inequalities. So if it's in the shaded area of one but not the other, it's not a solution to the system. It has to be in the shaded area of both and on a solid line and in a shaded area of both also counts. So we're going to see examples of that. So right now I have a system of inequalities graphed. I have a solid line and it looks like I've shaded everything below it, right? You got the yellow. Then I have a dotted line and I have everything shaded above it, the blue. And where yellow and blue come together, that makes green, right? So this is where they're both shaded. Okay, so all of my solutions would have to be in this green area or on this solid blue line. So I'm going to throw some points up and you think to yourself if this is a solution or not. So this point right here, is that a solution? No, it's not a solution to either one. It's not even in a shaded area. How about this one? That is a solution to the system because it's in the double shaded area. It's in the yellow and it's in the blue, right? So that's a solution. Is this a solution? Now this is a solution to the blue, but not the yellow. So this is not a solution to the system of inequalities. Same thing here. This is a solution to the yellow, but not the blue. So that's not a solution to the system. How about this guy? This was kind of tricky. It looks like it's on the blue line. So if you remember from inequalities, that is a solution to the blue line. It's also in this blue area, but it's not in the yellow area. So that is a solution to that system since it's on a solid line. Now let's take a look at this one. It's on a dotted line. That is not a solution to this inequality. How about this one? This one is on a dotted line. Now it's in the yellow, and that's good for this line, but it is on a dotted line. It is not a solution. So to see the difference between these, this one is covered because it's on this line. It's on the yellow line, right, where the shaded yellow, so it's included, and it's in the blue, but this one is on a dotted line. So that means it would not be included with the blue. And so that is not. This is not. Dotted line is no, solid line is. How about this one? This one is on the solid line. It covers the yellow, but it's not in the blue. And so that is not a solution. All right, so let's check it. So let's determine if the ordered pair is a solution to this system of inequalities. So it looks like that pair is right here. Okay, it's in a double shaded area. So this one is a solution to the system. Check yourself on this one. Is this a solution to the system? It is not. It's not a solution to either one. It's not in a shaded area, right? And it's on a dotted line, so it doesn't work. All right, let's try this one. It looks like we have a line shaded above and a line shaded below. And we have a point on a solid line. Okay, so this one is a solution because it's on a solid line. It's in the shaded. How about this one? Yes or no? So it looks like it's on a dotted line. So remember, that's going to disqualify it automatically. All right. Now, if they give you two inequalities, then you can graph the system and check to see if it's a solution or not. And so the first thing you're going to do is you're going to have to get y by itself so you can graph it. And so I know we've been doing this for a while, so I have this already pre-done for you. Remember, you subtract the 4x, and then you divide everything by 3, and then you get your slope and your y-intercept, okay? The other one, we're going to subtract the x. And when we divide everything by -3, you got to remember to flip that sign. If you don't flip the sign, then you're going, because you divide it by a negative, you're going to end up shading the wrong way and getting the wrong answer. So you have to memorize when to flip the sign. If you multiply or divide by a negative, flip the sign. All right, let's graph both of these. And so I'm going to start at -2. Then I went down 4 to the right 3. Dotted line, because it's not an equal to. And it's greater than, so we shaded everything above. Now, we learned all the shading and line rules when we did inequality. So if you need a refresher on that, you can go back and look at that 1 point, I believe it was 1.5, either 1.4 or that was 1.5 system of inequalities. All right, so now the green one, we're going to start at 3. We're going to go up 1 and to the right 3. So I start at 3, up 1 and to the right 3. This one is a solid line because of the equal to. And remember, we had to flip it. That made it greater than, so we shade everything above. So the place where they're both shaded, I have colored blue, right? It's above both of these lines. Now, to check to see if this point is a solution, we're going to plot that point, and we're going to see. When you plot that point, it falls right there, and that is a solution. It's in the double shaded area, so that is a solution to that inequality, the system of inequalities. So really, if you can get y by itself on one inequality and graph one inequality, then you can do it with 2. You just have to remember all the rules about it being in both shaded areas to be a solution of both. Okay, this one we can actually use the calculator on to help us. You can graph these in the calculator if you got y by itself. And when you put both of these in the calculator, it'll graph them both, and you can see where this falls. Now, I'm going to do this one by hand to help you out. So we've got y is less than or equal to -x plus 1. And so what I'm going to do is I'm going to start at 1. That's my y-intercept. And then this is a -1, which is really -1 over 1. And so I'm going to go down 1 to the right 1. And I'm going to do as many points as I need to be able to draw as straight a line as I can. And you've been watching my videos a while, you know my lines aren't very straight. Now this one is y is less than 3. Well, remember, this is understood, if you remember horizontal and vertical lines, this is going to go through the y-axis at 3. The y-axis, 3 is right here. It goes through the y-axis at 3. And you can see that's going to cover all the way across there. It's a dotted line, not equal to. All right, so now let's do our shading. On this line, it looks like it's less than or equal to, so we're going to shade everything below. All right, on this line, it looks like it's also less than or equal to. All right, so it's everything below that line. Now, I'm going to go through, I'm going to shade, I'm going to color in everything that's included. It's everything below both of these lines where the double shading is. Right? Now, it wants to know if the point -3, 3 is a solution. Well, I can go to the left 1, 2, 3, up 1, 2, 3. It's right there on that dotted line, so this answer would be no. That is not a solution to the system. Now, you can do this mathematically also. So if I take y is less than or equal to -x plus 1, we can evaluate. This is an x and a y. So I can plug those in. Y is 3. X is -3. So I have a -3. So let's see if it's true. Negative times a negative is a positive, so that's 3 plus 1. And you got 3 is less than or equal to 4. Is 3 less than or equal to 4? Yes, that is true. Okay, that's why it's setting right here, and it's considered to be in the shaded area. It's part of the shaded area. So this one works. Well, let's check the other one. You have y is less than 3, and so I'm going to use my y, which is 3. I'm sorry. And then it's going to end up being 3 is less than 3. Is 3 less than 3? No. That's why it's on a dotted line. And so since it failed this inequality, then it's not a solution to the system. Okay, so you can try this one on your own if you want, and then come back and check the answer. You have a system of inequalities. It looks like you have to solve for y on both and then check to see if 2, 0 is a solution. So pause the video, try it on your own, and then you come back and check. All right, you should be back now. So I'm going to solve this out real quick so you can see it. You got x plus y is greater than the 2. I'm going to get rid of the x like we always do, and you're going to get y is greater than negative x plus 2. Now, I'm going to go ahead and graph that one. So we got 2, down 1 to the right 1, and you can do as many points as you need to. It's going to be a dotted line because it is not equal to. It's just less than, and just greater than. And the symbol is greater than, so we're going to shade everything above. Now, to make it easier for us to see, I'm going to change colors real quick. Let's do this one blue. This one, I've got 2x minus y is greater than 1. We're going to get rid of the x like we always do. And now I have negative y is greater than negative 2x plus 1. Remember, that's understood to be a 1 there, so we're going to divide by negative 1. And since we divided by a negative, we have to flip that symbol. So now we have 2x minus 1. All right, so we're going to start at negative 1. And we're going to go up 1, 2, and to the right 1. And that's another dotted line. And this one is shaded less than, so it's going to shade everything below the blue line. So once again, I'm going to turn this one. Let's pick a different color. I'll do yellow. So this one is going to be in all the shaded area. So it's going to be right between here. I'm going to make this dotted a little bit bigger. And it's double shaded here. Right? So all of this is where solutions would be. All right. So now I'm looking at the point 2, 0. So let me go over here and plot that point. 2, 0 is right here. And that is on a dotted line. So once again, you should have found out that no, that is not a solution to that system. So this lesson is going to be really easy for you if you mastered solving inequalities, if you mastered graphing inequalities, because we're just doing 2 at a time. If you have not mastered that concept, you would need to come to tutorials, because now that's one of the things that we've done in the past that we should already be proficient at. And if you're not, then come into tutorials and let me help you get that down. Sometimes that one-on-one help can help you understand it better, and it will make this whole process easier. Same thing with the general solving. If we're not good at solving still, that's tutorials. We need to be in frequent tutorials, making sure we understand how to do that. All right, if you have any questions on tutorials, thanks for joining. Have a great day.